Hey everybody, I've been watching Jack Rickard's EVTV show now for well over a year. And of course I'm very interested in it because I've been working on a project myself. In a very recent episode, Jack was showing us a project that he's doing with a Volkswagen Thing. And he was showing us an inertia switch and talking about how he wanted to wire the inertia switch in series with the coil on the contactors, and so that if the car is involved in an accident, the inertia switch would release and the motor would stop, the car would stop moving. He also talked about adding a slap button up on the dashboard that would be in series with these things and would do the same thing. Just a simple whack of the button and boom, you're shutting everything off. These are great safety ideas. And I was really excited about it because that's exactly what I did when I was working on my car. As you see right here, I have an inertia switch here, or a collision switch. This one came out of a Jaguar. And up front, I have a red button, and if you slap it, you'll break the circuit here. Now, of course, the way the switch is designed here is that if there's a collision, the jolting of the car will release this switch, and its purpose primarily is to remove the electricity from an electric fuel pump so you don't have gasoline pumping out all over the place after an accident. So I've got mine in here, and I'll demonstrate it here for you in just a minute. But this is in series with 4 switches that I've got throughout the car. I've got the collision switch. I've got the slap button up front. Over here I've wired, but not completed, a switch that will be part of my charging system. The idea is that if I have the charging cable plugged into my car, I don't want to be able to drive the motor. So it will disable the motor until I remember to go unplug it. And then I have a third one, and that's this one right here, and you'll see an LED lit up there. I put LEDs in here because there's 4 different ways to disable this vehicle. And if I come out to my car and it won't run, I need to figure out what happened, what went wrong. Did I forget to unplug the charger cable? When I was in the grocery store, did somebody bump into my bumper and trip my collision switch? So I set it up so there would be an LED that comes on when one of the switches is open. That was a little bit of a challenge to me, to get a light to light when the circuit is open. But basically what I ended up doing was taking an LED and a limiting resistor and bridging the contacts. Like over here on this collision switch, this switch is closed. So these contacts right here short out the circuit that has the LED in it. This one over here that I still haven't told you about is open, and therefore there is a current flowing through the LED and the limiting resistor. That current goes through the whole path here. It actually goes through the coil of the contactors, but it's so little current there's not enough there to close the contactors, but there is enough to light the LED and let me know that nobody's sitting in the driver's seat. I had to reupholster the car, and while I was doing that, I thought, what the heck, I'll put a pressure switch in the driver's seat. These switches are inexpensive. I think it was about $14. They put them in garden tractors. Now you might think, that's silly. What do you think you need a switch on the driver's seat for? Well, I'll tell you what I was thinking. When you build an electric car, it attracts a lot of attention, and people want to see it. And sometimes you'll find a person who's fairly experienced mechanic, and they're used to putting their hands inside things and pushing things, and if they see something that'll move, they might want to mess around with it. So imagine this. Say I have the key to the ignition on, which I do right now. It wouldn't be on. This light wouldn't be on if I didn't. And let's say the car was in gear. It's not, but if it was, and this mechanic, know-it-all mechanic, says, oh, look at this lever. I wonder what that does, and starts moving it. That's our throttle pot. This is the throttle cable. If the car was in gear and if the key was on, this vehicle could suddenly leap forward, or worse, if it was in reverse, back over the idiot that's putting his hands where they have no business being. So that's why I have that one on there. So I've got the key on because I wanted to demonstrate the collision switch. So watch this. I've got a soft mallet here, and I'm just going to give this switch a tap. When I tap the switch, the button will pop up, and this LED over here should come on. So you see the button's up, the LED is on. That would disable the drive system by opening the contactors. Now, to reset it, you just simply push this button back down, watch the LED as the button goes down, it goes back off again. So that's how I set this system up, and it seems like that would be a pretty good idea. Howsomever, let's talk about this idea of opening a contactor in an emergency situation. I'm a ham radio operator, and about a year ago I had the opportunity to sit down with another ham who is a lot brighter than I am, and I was describing this situation to him and how I had set this up with the collision switch and everything in series that was going to open my contactor. And his eyebrows went up and he hesitated and looked at me. And you need to know, this guy's a lot smarter than I am. He's an electrical engineer. He's had a lot of experience designing and building circuits. And he knows about turning high power loads on and off. So he gave me quite an education about contactors. And let me share with you what he taught me. We use electrical contactors in a lot of places when we want to turn high voltage or high current loads on and off. Most of us will have them somewhere in our homes. If you have an electric forced air furnace, for example, there'll be a contactor in there so that a low voltage on a thermostat can turn a high voltage on and off in your furnace. You might find them in the oven of your stove. You might find them in other appliances throughout your house. What he explained to me was those contactors work well and do what they're supposed to do because we're talking about alternating current. And when you're dealing with a contactor and you're dealing with AC current, it's very different from when you're dealing with a contactor and you're talking about DC current. And so this is what he explained to me. Imagine the plates of a contactor are closed right now, like the contactor in an electric furnace. And the thermostat wants to shut that heater off. And so what it's going to do is it's going to release the voltage to the coil, and the contactors are going to spring open. Well, we're talking, maybe 240 volts here running possibly only 30 amps. And when you open those contactors, that current doesn't want to just stop flowing. It really wants to keep going. But an interesting thing is going on when we're talking about alternating current. You see, alternating current is changing directions back and forth here in the United States 60 times a second. And if you think of a sine wave, that means that twice every 60th of a second, that alternating current goes to 0 amps. So when those contactors spring open, if it wants to spark, if it wants to start to arc within 1/120th of a second or less, the current flow on those contactors is going to drop to 0 amps. That will completely extinguish an arc if one even starts to begin with. Now my car, it's not AC. I'm driving down the road. I've got about 135 volts on my battery pack. I'm doing 50, maybe 60 miles an hour. I'm traveling along the road and another vehicle runs a red light and pow, smacks into me. My collision switch pops open. It expects my contactor to jump open. But this is DC. So I may be running, let's say, 130 amps through there at that moment. And when those contactors open, that current is not going to stop. it is just going to keep right on flowing right through the air. To use his words, he said, "Bud, you no longer have a contactor, you have an arc welder." So where you think you're trying to solve a problem, you're actually creating a new problem. And who knows what could happen once we get that thing arcing over there. Plenty of options, and none of them are good. So there is a solution to all this. And what's really interesting is if you go back and you watch Jack's video when he introduced that inertia switch, about 90 seconds later, he named the solution to the problem. He didn't connect the two together, but I will now, so that we all can understand that there is a safe way to do that, to do this, but simply opening the contactors on a DC circuit like this is not going to do the job. Let's take a look at my car again. Well, let's take a look here. We'll review a little bit about our throttle here. The throttle that I'm using on the Volkswagen uses the original throttle cable that went to the carburetor. It goes through the car, same as it did before, and it uses the original pedal. When I got my motor kit, it included this throttle pot. Basically what it is a variable resistor here, or potentiometer, that is attached to a bar, and I built these brackets and put the spring on it so that when you put your foot on the pedal, you're moving the shaft of a potentiometer. And as we increase the resistance in that potentiometer, that increased resistance tells the Curtis controller that we want the motor to go faster. Part of the safety mechanism built into this throttle pot is a series of little switches in here. And it's designed so that if someone who's not used to driving an electric car sits down and goes to start up, if they do what they're used to doing, maybe in a gasoline-powered car, where they want to put their foot on the pedal first and then turn the key and turn the ignition to start the motor, that's not what we want to do with an electric car. So it's designed so that if you turn the key on with your foot already on the throttle, the motor will not turn. There's a line here that comes from the controller that disables the controller. And Jack mentioned that line in the video, as I had said. So my solution to this arcing problem was to go into the hardware store in the automotive department and get myself a simple little 12-volt relay. The 12-volt relay is in series with all of my safety switches and the coil on the contactor. And I'm running the disable line that is supposed to go from the controller to the switches on the pot through a relay. So if we have a situation then where we need to suddenly turn off the power to the motor, we have to open our contactor over here while we are running high current through it. Two things happen. The contactor will open, but this relay will open also, which activates the disable line on the Curtis controller, and so the current immediately drops. So if there is any arcing that might be going on when we suddenly open those contactors, by disabling the controller, we drop the current to zero, and we're able to extinguish any arc that might occur there. So if we're going to have a safety function, such as a switch that will disable things in an accident, or a slap button that you hit in an emergency, we have to do two things. We have to open the contactor, and we have to remove the load from the circuit. We've got all the leads and wires coming from our controllers to do that. Both have to occur. You need to do both things. Well, hey guys, that's it from here for now. I wanted to share these things with folks, and I appreciate that opportunity. You know, the nice thing about the EV community is that we can learn from each other. And this was something that I didn't know, that I learned, and I really appreciated the fact that I had a friend that could explain this to me so that I could understand it. In the end, it was really easy to do and implement, and I feel much better knowing that I did it right. And so I appreciate the opportunity to share it with you, and hopefully it's something that you will consider in your own projects. But for now, that's great. And Jack and Brian, I really enjoy your show. Keep up the good work, and thanks for letting me share with the guys on EVTV.